51. How much heat is required to convert 422 grams of liquid H2O at 23.5 degrees Celsius into steam at 150 degrees Celsius? Okay, that's all they give us. So let's try to figure it out. Now the question here is we want to find out how much heat is being produced. And heat in chemistry is always a Q value, right? So we're basically solving for a Q. Now, there's a couple of different formulas that is running through my mind right now that have to do with Q. And they're written down here for reference. Well, we'll get into those in a little bit. But first, always try to write a roadmap, especially when you start changing phases. Now, for example, we're starting off with a liquid H2O. So we're starting off with H2O liquid. So that means that I'm starting off with H2O as an L, but then they say that I'm turning into steam. And what type of phase is steam? Yeah, it's H2O as a gas. So once you're starting at one phase and you're winding up at a completely different phase, especially if they're asking for heat, always write a roadmap. It will help you out. So let's try to write that roadmap out. Now the roadmap always consists of the starting temperature and the ending temperature. So we're starting at 23.5 degrees Celsius, and I need to heat this water up all the way to 150 degrees Celsius. So I'm just going to start there. So I'm going to start at 23.5 degrees Celsius, and I know that I have to go all the way to, maybe I'll go like that, 150 degrees Celsius. Now, for phase changes, we should remember certain temperatures for water. And there's only two temperatures that we have to know. There's 0 degrees Celsius, and maybe I'll write that out over here. So for water, and water only, so I'll say H2O. The two temperatures that you have to worry about is 0 degrees Celsius and 100 degrees Celsius. 0 degrees Celsius is when your solid, your ice, will melt into the liquid. And for 100 degrees Celsius, if I could maybe just pull this back a little bit, 100 degrees Celsius is when the liquid will evaporate and turn into a gas. Now, do we come in contact with any of these two temperatures? Because those are your phase changes. Well, I'm too high to be dealing with 0 degrees Celsius. I'm starting out as 23.5 degrees Celsius. But as I'm going from left to right, as I'm trying to get to 150, I will cross 100 degrees Celsius. Somewhere around here, let's say, right? Somewhere in this vicinity, that we will reach 100 degrees Celsius. That's a really important temperature because this is where my liquid, or the water, will turn into a gas. So now I have different steps, and here is your blueprint. Now just know that anything from 23.5 degrees Celsius to 100, the water is going to be in a liquid phase. At 100, it then changes to gas, and then from 100 all the way up until 150, that water is now in the, yeah, you got it, it's in the gas phase. So, seems like we have 3 different steps going on here. We first have to find out the total amount of heat to get the water up to 100. Then we need to know how much energy it will take in terms of heat to actually phase change, because that costs energy, that costs heat. And then we have to see how much it will go from 100 up to 150. So we can think about this in terms of steps. So this is going to be step number 1. Let's figure out how much heat is required to go from 23.5 degrees Celsius all the way up until 100. Now you say to yourself, is this a temperature change or is this a phase change type of question? Yeah, we're changing temperature here. So this is totally a temperature change. Oop, what happened to that C? This is totally a temperature change. And anytime that you're dealing with temperature changes, especially when you're dealing with heat, you're going to use Q equals ms delta T. Now, you might know it in class as Q equals MC delta T. Doesn't really matter, C or S. S I just like to use because S is for specific heat, the S in specific. But you could use either one. So I'm going to write Q equals ms delta T. Let's see what we got. Q is what we're solving for, so that's going to be the X value. M is the mass, and they did tell us how much mass we have. We have 422 grams, so that totally checks out. Now the S number, they did not tell us the specific heat of water, but that's one that we should memorize. Definitely the water one, and that's the one that I wrote down here. For liquid water, the S value is 4.184 joules per gram degree Celsius. Okay? And now the delta T has its own formula within a formula. Maybe I could write it over here. Delta T, remember, that's always the final temperature minus the initial temperature. And remember, in this step, we're only going from 23.5 degrees Celsius to 100. So the initial was the 23.5. TI was 23.5. The final, TF, was 100. So if it's final minus initial, it's 100 minus 23.5. So let's just see whatever that is, right? 100 minus 23.5. We get 76.5 degrees Celsius. And just know that this is one of the only formulas in chemistry in which you can keep the Celsius unit, mainly because your specific heat has Celsius in it, so the temperature units have to match. So let's go for it. We have ms delta T. The M was 422. The S was the specific heat of water, which is always 4.184, and the delta T for the first step is 76.5. Okay. So 422 times 4.184 times, let's just pull up that number. That's why I love the TI-84. Just checking to see that all the numbers are good to go. Looks good to me. Press enter. And technically, since this is not the final answer, we shouldn't really round. So I'll just say 135072. And that's in the unit of joules, because the specific heat unit had the unit of joules in there. All right, so we got one Q value. And maybe what I'll do is I'll just say that this is really a Q value. Because Q was X, X was Q, tomato, tomato. But anyway. Maybe I'll just get rid of these X's and I'll call this Q. And we'll do that for the rest of them. Just so that, there you go. Okay. But if you want to put in the X value, that's totally fine. Doesn't matter. But here is the first amount of heat that's needed. So you need like 135,000 joules just to get that water up to 100 degrees Celsius. So the first step is done. Now comes the second step. And the second step is you got to phase change before you move on. So this is step number 2. So I'm going to write that out here. Maybe we'll put like a little beep. There you go. Step 2. Now, all this is just the liquid water converting into a gas at 100 degrees Celsius. So you say to yourself, is this a temperature change or is this a phase change? Yeah, now this is a phase change. So I'm going to use the other formula, which is Q equals N delta H vaporization. So we're still solving for that heat. So we need to know what N is and we need to know what delta H is. Now N is the number of moles of the substance. So we're not dealing with an M anymore, no more mass. For your phase changes, chances are you're going to be dealing with moles. But, they didn't give us the moles, right? They gave us grams. So the first thing we would have to do is just convert the 422 grams of H2O and convert that into moles, right? Now, we're way past dimensional analysis, right? We can easily know the tricks. But if you want to do dimensional analysis, you always can. But just know that from grams to moles of the same substance, which is water in this case, all you have to do is just divide by the molar mass, which I'll call mm. So we just have to look on the periodic table just to see what H2O is. And on my periodic table, I have 2 hydrogens. And for the hydrogens, it's 1.008. And then I'm going to add just 1 oxygen on my periodic table at 16. So I'll take the exact value here. So I'm just going to divide by 18.016. And I will get my moles. So 422 divided by this number. Okay, technically you shouldn't round because this is not the final answer. So I guess we'll say 23.42. Keep rolling with it. So now we know what the moles are. Beautiful. But we need to know the delta H of vaporization. Now this is a standard number for whatever substance you're using. In this case, we're using water. So here is the delta H of vaporization. It's 40.66 kilojoules per mole. On a test or quiz, hopefully your professor or teacher gives you that number, but you might have to memorize it. So I would just double check. And the units for the quantity matches. We have mole for the delta H and mole for the N value. So that's also another way how you can see, what units you're using. Let's now just solve. Q equals 23.42 times the 40.66. And if you want, we could just take this whole number, bring it down, times it by 40.66. Enter. Okay. So we got 952.405. And that's now in units of kilojoules because the delta H value had a kilojoule unit in there. All right. So let's keep going. Now we're in step 3. Almost there. Because now we have to go from 100 degrees to 150. So step 2 is done. Let's just do a check mark here. And now we have step 3. So step 3 is now picking up where you left off. We're now at 100 degrees Celsius. Maybe I'll write that in blue. We're at 100 degrees Celsius, and we're going all the way to the final result, which is 150. You say to yourself, is this a temperature change or is this a phase change? Yep, this is a temperature change. So we're going to be using the same formula as we used in step number 1. All temperature changes are Q equals MS delta T or MC delta T, whichever you prefer. We're going back to mass. So the mass was 422. Now the S value, you might say that's 4.184, but the 4.184 is for liquid water. Are we a liquid anymore at this step? No, we're a gas. So the gas, H2O, has its own specific heat, which I wrote down here. So that's how these can get a little tricky. Since you're in gas form, I now have to use 1.864 joules per gram degrees Celsius. So just be careful about that. Delta T is the temperature from start to finish of that step. So the initial temperature is now 100 degrees Celsius, and we're going all the way to a final temp of 150. So this would be TF minus TI, so 150 minus 100. We get a delta T of 50 degrees Celsius. Now we got everything. Let's plug it in. MS delta T, 422. The S number is 1.864. Delta T is 50. Let's find out that Q. 422 times 1.864. That looks good to me. Times 50. Just double checking that all my numbers are good. Okay. And we got 39330.4. And since the S units have joules, for this formula, generally it's going to come out in joules. All right. Now we have the total heats at every single step. But the question said, how much heat was required to do the whole shebang? So we're basically looking for the total amount of heat. So what do you think we have to do with these three values? Yeah, you got it. We got to add them up. But did you see the catch? Joules, kilojoules, joules. I can't just add these up because they're not the same units. So first you have to make them all the same units and then add them together. Now it doesn't really matter whether you go to kilojoules or you go to joules. These are pretty big numbers. So we might just want to convert to kilojoules for all three of these. So let's do that and then we'll add them together. Now just remember that joules to kilojoules is always, and maybe I'll just set it up here, joules to kilojoules is always just dividing by 1,000. So for step number 1 and step number 3, all you have to do is just divide by 1,000, or you can take the decimal, move it over to the left 3 times. So this would be my new Q, which would be 135.072 kilojoules. Okay. The second one, we don't have to do anything because that's already in kilojoules. And then take the decimal, move it to the left 3 times. So this would be a new Q of 39.3304. Okay. Now we're ready. Add up Q values. So we have 135.072 kilojoules plus the 952.405 5 kilojoules plus the 39.3304 kilojoules. And this will be your total heat. So maybe I'll just put it up here. Total heat equals, let's see, 135.072 plus 952.405. Just triple checking that all these numbers look good. 952.405. And then plus 39.3304. 39.3304. Press enter. And seems like we're good to go. Now, if we wanted to convert, seems like maybe 3 sig figs. So I'm just going to say 1130 kilojoules if we had the 3 sig figs in there. But if your teacher or professor doesn't care, you could just add the whole number. But this would be the complete answer. Okay. Whew. Crazy question, but I've definitely seen these on tests before, so just make sure that you can go through the whole motion. Don't be afraid to write out that blueprint. And let's just give this last step a check, and we're all good to go. Okay. Thank you so much for viewing the video. I hope you're having a great day out there. Keep studying hard. And yeah, thank you for being part of this community. It's awesome, what this channel has done for all you guys all over the world. Thank you for your kind comments in the comment section. And I hope you all well. And I'll talk to you soon. All right. Bye-bye.